Hello everybody, welcome to Virtual School Physics is Fun. This is Puan Liao. Okay, today we are going to learn refraction and we are mainly going to concentrate on refraction of light wave. Yeah. Now what is refraction? Refraction is actually bending. Bending. If we talk about refraction of light, so it is bending of light. So when does it bend? As you can see from this picture here, as light travel from air into this piece of glass, it bends. Right? As it comes out to the air, it bends again. So this bending of wave or bending of light is called refraction. All right. So when does it bend? As it enters from air to the glass, glass have got different optical density than the air. Basically, the glass is of higher optical density than the air. Okay, so as it enters this piece of glass, which is of higher optical density, it slows down. The speed changes. So because of this change in speed, so light bend. All right, let's recall the basic concept of refraction. Now, this is incident ray. This is refracted ray. This is normal. So normal is a line that forms 90 degree. That is 90 degree to the boundary between the two medium. Okay, so angle of incident is the angle made by the angle of, by the incident ray and normal, and we call it I. So angle of incident is the angle between the incident ray and normal. Similarly, angle of refraction is the angle between the refracted ray and the normal, and we call it R. So it is always with the normal. The angles formed is from the normal, never from the boundary between the two mediums. Now, as light travels from air to a medium of different optical density, for example, from the air to water or to glass, air in the air, light travel faster as compared to in water or in glass. So it travels slower. Okay, so air is of lower or less dense, lower optical density, so it's less dense, so light travel faster compared to in a more dense medium. Okay, light travels slower. So when light enters a denser medium, for example, water or glass, so the speed slows down, the speed decreases, and it bends towards normal. You can see it bends towards normal. What do you mean by bending towards normal? So as you see, this dotted line shows if the incident ray does not bend. If it does not bend, it will follow this path. But now it is this, the refracted ray is this. So meaning to say it has bent towards normal. Normal is here, so it has bent towards normal. Okay, so from less dense to more dense, the ray refracted towards normal. Conversely, if it is traveling from more dense to less dense, okay, more dense to less dense, so light travel slower in a more dense medium and faster in a less dense medium, so it will refract away from normal. All right, so you see this is normal, this is normal. If it does not refract, it will follow this dotted line path, but now it refracts away from this normal. All right, so it travels away, it bends away from normal if it's traveling from less dense medium to more dense medium because it is moving faster. All right, as we make a summary here, from less dense medium to more dense medium, light will bend towards normal. Conversely, if it is from more dense medium to less dense medium, it will bend away from normal. Okay, can you remember? All right. So if we have light ray travel into a more dense medium, for example, glass, and then after that shines out from this glass. So this ray that it comes out from the glass is called emergent ray. So we have three rays here: incident ray, refracted ray, and the emergent ray, right? So you can see, what can you say about this incident ray and emergent ray? Okay, if I extend the incident ray, you see, if I extend the incident ray, you can see very clearly that the incident ray and the emergent ray, they are parallel to one another. All right, they are parallel. Okay, now what if light rays enters a medium without any incident angle? Yeah, when I is equals to 0, so it enters from the normal. Yeah, at where the normal is, as you can see, light enters straight without bending. Yeah, it does not bend. So this will happen when incident angle is equals to 0, because we know when incident angle equals to 0, refracted angle is equals to 0. Okay, so there is no change in direction, it does not bend, but only the speed changes. Yeah, it slows down only. Okay, so this is a refraction of light. We will end here and we will continue some other time. Bye bye. Thank you.